So is the code of eye detecting eye color. Okay, so what we do, it's a function that returns the eye color, and it takes the input as a image file. Now first we have done what we have done, we have resized the image to a standard image, standard size 300 cross NaN. NaN will retain the aspect ratio of the image and corresponding to the height. So this means the number of rows, and this is corresponding number of columns. Number of column will automatically adjust according to the aspect ratio. Now what we have done here, we have basically used Weiler-Jones algorithm. Here is it: vision dot cascade object detection system object. Now what cascade object detector does, it basically detects objects in a given image, and based on the training function, training, it depends, it will try to predict, it will try to find the location of that particular object in the input image. So here we have passed eye pair big, so it will try to find the location of eye pair inside a particular image. For example, this is a particular image, so it will try to find the location of eye pair. It will try to it will create a bounding box that will hold the both eye pair. Now once the object is prepared, the system object is made, and what we do, we use the step function in order to find the eye pair inside the input image, where image is a resized image. Now if there is a particular face, a human face inside the image, then it will find the location, or it will give you the coordinates of that particular eye pair location. Basically, it will give you a rectangular bounding box denoted as BB, and BB will hold four values: X, comma Y, comma W, comma H. Okay. Basically, it will give you X, comma Y, comma W, comma H. X and Y is the starting coordinate. For suppose this is a rectangle and starting point is his. This is XY location, and this is width, and this is height. Now, if the BB has four values, that means IPR is detected. Then show the particular image, show the original image, and crop the image according to the IPR location. So it will find only the part. It will give you the cropped image of only image, or of only eye, and show that particular eye location. Now what we have done here is we have basically distributed all the RGB component of the eyes. So eyes 1 colon colon comma 1 means R part. This is G, this is B part. Okay. Now what we have done here is we have find out the number of rows and number of columns inside this eye, and we have basically what we have done is we have divided the whole image into left eye and right eye part. So we are basically taking only the right, only a location of a single eye from the eye pair. So we are basically dividing into half the image. We are basically dividing into half to get only a single eye, so we can focus on the eyeball part and try to find the eye location, and correspondingly get the color from the eye. So it will get only this part. So from the R part, G part, and B part, and after dividing this RGB part of the whole eye image, we are catenating all the three parts. Okay, and it will be displayed on the screen. Now detecting the eye color. Now what we have done is uh, now what we are doing here is we are basically creating a threshold for different eye colors. For suppose black eye, blue eyes, green eyes, and hazel eyes. So let's see the function. Black eyes. So black eyes, what will it will do? It will first of all segment the image into various threshold according to the various threshold. So it will basically threshold the whole image according to the given upper and lower bound of the thresholds. For red, upper and lower bound; green, upper and lower bound; blue, upper and lower bounds. So according to that, it will create a red, green, and blue mask. And depending on the mask, the final outcome will be derived. Okay, and likewise for blue eyes, the threshold will change. As you can see, threshold changes for blue eyes, and likewise for brown eyes, the threshold changes. The threshold is different. So it will basically find the color. If black has what is the basic output color? Black for blue and for green, brown, green, and hazel. And then what it will give you basically a matrix of eye part, and depending on the color present in that particular eye, it will give the output. So for suppose if an image all in an image the eye is black, then black part will be more. This well, the value of black will be more, and the value of blue, brown, green, and hazel will be less. So according to that, according to the value of these variables, we can identify what is the color of the particular eye. So what we are doing in here, what we are doing, uh, we are basically applying the same technique or same condition कि अगर the value of black is much greater than all the different values. Suppose the value of black is greater than blue, the value of black is greater than brown, value of black is greater than green, value of black is greater than hazel, then it is a black eye. Then eye is black, and we have denoted we have made a variable eye color. So it is the output variable. Then output will be given as 1. 1 means black, 2 means blue, 3 and likewise 4 and 5. Okay. So this is the whole algorithm, and if there is no eye in the particular image, so it will give the eye not recognized. So this is the whole algorithm of how the eye color is determined from the input image.